Every time we turn on a light, watch TV, or open a refrigerator, we use electricity. But where does all this electricity come from? In this video, we'll follow its amazing journey to our homes. We need massive amounts of electricity every day. A single lightning bolt has enough power to light 100 lamps for a day. But that's not nearly enough for all our homes, schools, and hospitals. Most of our electricity is made in big buildings called power stations. These are like giant electricity factories that make electricity and send it to our homes through cables. Many power stations burn something called fossil fuels to make electricity. The fossil fuels are coal, oil, and natural gas. They're called fossil fuels because they formed from ancient plants and animals that lived millions of years ago. When fossil fuels burn, they release heat. This heat can boil water and turn it into steam. The steam pushes giant wheels called turbines. As the turbines spin, they generate electricity. But there are two big problems with fossil fuels. First, we'll eventually run out of them. They take millions of years to form. Second, burning them creates pollution that harms our planet. That's why we're using more renewable energy. Renewable means it won't run out and can be used again and again. The sun, wind, and flowing water can all be used to make electricity without running out. Solar panels capture sunlight and turn it directly into electricity. They work best on sunny days. In just 1 hour, the sun gives Earth more energy than all humans use in a whole year. Wind turbines are like giant pinwheels. When the wind blows, they spin around and create electricity. Some are taller than a 30-story building. Flowing water can also make electricity. Huge dams trap water in reservoirs. When the water flows through the dam, it spins turbines to make electricity. This is called hydroelectric power. Another way to make electricity is nuclear energy. This doesn't create air pollution like fossil fuels, but it needs special care to keep it safe. Once electricity is made, it travels through big metal cables held up by tall towers called pylons. These cables bring electricity to our towns and cities. Then smaller wires bring it into our homes. When you plug something into a wall socket, you're connecting to electricity that might have been made hundreds of miles away. The electricity flows through the wire and into your device. Try this at home. Count how many things in your kitchen use electricity. Which room in your house has the most electrical devices? You might be surprised. Remember, power stations make electricity using fossil fuels, renewable sources like the sun, wind, and water, or nuclear energy. The electricity travels through wires to reach our homes, and this amazing journey happens in an instant every time we flip a switch. If you think electricity's journey is awesome, hit the like button. Next time, we'll look at how electricity travels in paths called circuits. Why do electrical wires have plastic around them? Why are switches made of metal and plastic buttons? In this video, we'll discover which materials let electricity pass through them and which ones stop it. Scientists test materials using a simple circuit with a gap. If we put something in the gap and the bulb lights up, electricity must be flowing through that material. Materials that let electricity flow through them are called conductors. The word conduct means to let something pass through. Conductors let electricity pass through easily. Most metals are excellent conductors. Copper, aluminium, iron and steel all let electricity flow through them easily. That's why the wires inside cables are made of metal. The best metal conductor is actually silver, but it's expensive, so we usually use copper instead. Gold is also an excellent conductor. It's sometimes used in expensive electronics because it doesn't rust. There are a few other substances that also conduct electricity too, such as water with dissolved materials in it, like tap water or seawater. That's why we're warned never to use electrical devices near water. Materials that block or stop electricity from flowing are called insulators. They're like electricity bouncers saying no entry. Plastic, rubber, glass and wood are good insulators. They resist the flow of electricity and keep it contained. That's why the outside of wires is covered in plastic and why light switches have plastic buttons. Electricians sometimes wear rubber gloves and rubber-soled shoes because rubber is such a good insulator. It helps keep them safe when working with electricity. When we test a paperclip, the bulb lights up. It's a conductor. But when we test a rubber band, the bulb stays off. It's an insulator. What do you think would happen with a piece of wood? We use conductors and insulators together to make electricity work safely for us. The conductor lets electricity flow where we want it to go, while the insulator keeps it from going where it shouldn't. Look inside an electrical wire. The metal core conducts electricity, while the plastic coating insulates it. This combination lets electricity travel safely from place to place without escaping. The human body is actually a conductor because it contains water with dissolved minerals. That's why we can get an electric shock if we touch exposed wires. Electricity can flow through us to the ground. Try this at home if you have a simple circuit. Test different objects to see if they're conductors or insulators. Make predictions first, then test safely. Remember, only test with low voltage batteries, never wall outlets. In our next video, we'll be looking at electrical safety, and you can find that video here. You can also check out our full electricity lesson playlist. In this video, we're going to look at the parts of a circuit. Have you ever had a toy or torch that wouldn't work? To understand why, we need to learn about circuits. In this video, we'll discover how electricity needs a complete path to flow. A circuit is a complete path or loop that electricity flows around. The word circuit comes from circle. Electricity needs to travel in a complete circle to work properly. Most small circuits start with a cell or battery. A cell is a small container of chemicals that create electricity. Two or more cells together make a battery. The battery pushes electricity around the circuit. A battery's pushing power is called voltage. The higher the voltage, the harder it pushes electricity around the circuit. It's like the strength of water pressure in a hose. Wires connect the different parts of a circuit. They're made of metal, usually copper, inside a plastic covering. The metal lets electricity flow through it, while the plastic keeps the electricity safe inside. The different parts of a circuit are called components. Batteries, wires, bulbs and switches are all components. Each one has a special job to do. A bulb creates light when electricity flows through a tiny wire inside it called a filament. The filament gets so hot it glows brightly, and that's how we get light. Here's a simple circuit. The battery pushes electricity through the wires to the bulb, which lights up and then back to the battery again. It's a complete loop with no gaps. If there's a gap or break anywhere in the circuit, electricity can't flow. It's like a roadblock. The bulb won't light up because the electricity can't make a complete journey. A switch lets us turn electricity on and off without unplugging anything. When the switch is closed, electricity can flow through it. When the switch is open, it creates a gap and stops the flow. A buzzer makes a sound when electricity flows through it. Inside, electricity makes a small piece of metal vibrate really quickly, and this creates the buzzing noise. You'll find buzzers in doorbells and game shows. A motor spins around when electricity flows through it. Inside, electricity creates a magnetic force that makes parts rotate. Motors can power fans, toy cars, and washing machines. Scientists and engineers use special symbols to draw circuits. It's like a secret code that's much quicker than drawing the real things. Try this at home if you have a battery, bulb, and wires. Create a circuit to light the bulb. Then try adding a switch. Remember, a circuit needs a power source like a battery or cell, wires to carry the electricity, and components like bulbs, buzzers, or motors. Everything must connect in a complete loop with no gaps for electricity to flow. If you learn something new, hit the like button. Next time, we'll explore which materials let electricity flow through them and which ones stop it. You can also check out our complete electricity playlist. Electricity helps us every day, but it can also be dangerous if not handled properly. In this video, we'll learn how to stay safe around electricity and why it needs to be treated with care. Electricity always tries to find the fastest path to the ground. It's constantly looking for conductors that will help it get there. This is why we need to be careful around it. Our bodies contain water with minerals dissolved in it, making us good conductors of electricity. If electricity passes through our body, it can cause harm on its way to the ground. A small static shock from a doorknob might surprise us, but it's not dangerous. However, the electricity in our homes and from power lines is much stronger and can cause serious injury. A very serious electric shock is called electrocution, which can cause severe injuries or even be fatal. That's why we have special safety rules around electricity. At home, never overload sockets with too many plugs. This can cause overheating and fires. Ask a grown-up to check if you're unsure about plugging something in. Keep electrical items away from water. Remember, water is a conductor. Never touch electrical switches or appliances with wet hands or while in the bath or shower. Check that cords and cables aren't damaged. If you see bare wires or fraying, tell a grown-up immediately. Never pull a plug out by yanking on its cord. Outdoors, stay away from power lines and electrical substations. Never climb electricity poles or trees near power lines. Don't fly kites or drones near them either. During thunderstorms, lightning can strike trees, water, or high ground. It's best to be inside a building. If you're outside, stay away from tall objects and open spaces. Look at a plug. It's made with plastic on the outside and metal pins. The plastic is an insulator that stops us from touching the metal parts where electricity flows. Inside plugs and electrical boxes are special safety devices called fuses. If too much electricity flows, the fuse breaks the circuit, stopping the flow before it causes damage. If you notice anything unsafe about electricity, like a damaged cord or a strange buzzing sound from a socket, tell a grown-up right away. Never try to fix it yourself. If someone gets hurt by electricity, never touch them. You could get shocked too. Call for an adult immediately and tell them to call emergency services. Try this at home. Make a poster showing electrical safety rules for your family. include at least 3 important safety tips that we've learned today. Put it somewhere everyone can see it. Remember, electricity always seeks the fastest path to ground. Keep electrical items away from water. Don't overload sockets. Check for damaged cords. Stay away from outdoor power equipment. And always tell a grown-up about any electrical problems. If you think electrical safety is important, hit the like button. Next time, we'll discover how electricity has changed the world throughout history. Imagine a world with no light switches, no computers, no refrigerators, and no phones. That was normal just 150 years ago. In this video, we'll look at how electricity has completely changed the way we live. Before electricity came to homes, people used candles and oil lamps for light. They kept food cool in ice boxes with actual blocks of ice. Washing clothes meant scrubbing by hand for hours. People have known about static electricity for thousands of years, but it wasn't until the 1800s that scientists really began to understand how to make and use electricity. In 1879, Thomas Edison created a light bulb that could stay lit for many hours. Before this, people's days ended when the sun went down. Electric light changed people's sleep patterns and allowed them to work and play after dark. Another inventor, named Nikola Tesla, helped develop ways to send electricity over long distances. His work helps power our homes today. He even created some of the first remote-controlled toys over 100 years ago. At first, people were unsure about having electricity in their homes. Many were afraid of it or didn't see the need for it. Rich people got electricity first, often just for lighting. Electricity revolutionized how we communicate. First with telegraphs, then telephones, radios, televisions, computers, and now smartphones. We can instantly talk to people on the other side of the world. Electric appliances have made housework much easier and quicker. Washing machines, vacuum cleaners, dishwashers, and microwaves save us hours of hard work every day. Hospitals use electricity to power life-saving equipment. X-ray machines let doctors see inside your body without surgery. Some people even have electrical devices inside their bodies, like pacemakers that help hearts to beat properly. Think about how you have fun. Television, video games, music players, theme park rides, all are powered by electricity. Without it, entertainment would be very different. Computers and the internet have changed how we learn, work, and play. You can access more information instantly than people could find in their whole lifetime just 100 years ago. Today, about 90% of people around the world have electricity. But that means 1 in 10 people, and that's about 800 million people, still live without electricity. Many are in Africa and Asia. Without electricity, there's no refrigeration to keep food fresh, no electric lights for studying after dark, and no easy way to charge phones or access the internet. Everyday tasks take much longer. The way we make electricity is changing too. More solar panels, wind turbines, and other renewable sources are being used. Homes are getting smarter with devices that use electricity more efficiently. Try this at home. Ask older family members what electrical devices they didn't have when they were your age. What surprised them most about electricity and how it was used? How did they do things differently? Remember, electricity has transformed how we live in just 150 years. It's changed how we communicate, work, learn, stay healthy, and have fun. But many people still don't have access to this amazing resource. Congratulations, you've now completed our electricity series. You now know what electricity is, how we produce it, how circuits work, about conductors and insulators, how to stay safe, and how electricity's changed our world. Hit the like button. And don't forget to check out our other science playlists to keep your learning flowing. Why not check out one of our other Year 4 playlists, such as States of Matter or Sound?